Hello. This video provides a demonstration of the toolset that was developed as part of CRCSI Project 4.5.1, also known as Greening the Gray Fields. The toolset was developed using a number of open source software packages, including a Postgres database management system that acts as the back end, and the Quantum GIS geographic information system that acts as the front end. We developed the toolset as a plugin in QuantumGIS using the Python programming language. The toolset was developed in Module 2 of the project with the aim of creating a spatial decision support system to identify priority redevelopment areas in aging middle suburbs. And once the tool is loaded up, the first tab gives a brief introduction to the toolset in the project. You can also load a Google hybrid layer as a base map, but I won't do that at the moment because it tends to slow things down a fair bit. And in our project we have two local government partners. In Western Australia it's the City of Canning, and in Victoria it's the City of Manningham. But because I'm more familiar with the Western Australian case study partner, we'll go ahead and select that and load the base map for the City of Canning. And that's just going to load up the cadastre for that local government area, which is approximately 32,000 properties. And if users wish, they can view buffers that have certain strategic significance. For instance, the small orange circles, so 200-meter catchments around neighborhood or local centers. The slightly larger orange circles show 400-meter catchments around district centers. And these orange buffers along these corridors here are activity corridors, 200-meter catchments. And the small and larger blue circles are 400 and 800-meter catchments around train stations. But for the time being, I'll just go ahead and turn those off. Now, the first tool in the tool set is a MultiCriteria Valuation tool. In the first stages of the research, we actually dived straight in and wanted to identify which properties would be coming up for redevelopment in the near future. And in that way, if you can anticipate where redevelopment is likely to occur, then maybe local government and developers can act ahead of time and try to facilitate a better redevelopment outcome. But what we witnessed or realized when we started visiting some of these sites that we identified as being ready for redevelopment was that some of these areas lacked some strategic context. So this is why we put this tool at the beginning. So the MultiCriteria Valuation tool allows you to select a number of property attributes, demographic attributes for the area, and a number of location attributes as well. So one market segment to provide new housing for in the City of Canning that was identified was for an aging community. So if you want to look at areas where there's a larger older population, as well as it was identified that for an aging community it's important to have access to parks, bus stops, neighborhood centers, and local centers. But in addition to selecting which parameters we're interested in, we can also give them a weight. So leaving them all a weight of 10 would give them all equal weighting. However, we might want to give a slightly higher weighting to an older demographic. Right? We might put a larger weight on local centers than we do neighborhood centers. Bus stops we can leave around there, but we also know from, maybe we'll lower that a bit. We also know from our engagement with our local government partners that parks are very important. So let's try that. So this is going to run for a few seconds, but it's going to produce a thematic map where areas of red rate low in terms of our indicators and the weightings we allocated to them, and areas of green are more favorable from a strategic standpoint. And these weightings and these decision criterion, we expect that users would end up deliberating over them and discussing these weightings in a collaborative approach. So I'm actually just going to go ahead and add another color to the color ramp because using Python I didn't have the functionality to do that. I'm also just going to go ahead and remove boundary lines so the different colors become more striking. So then again, areas of green would be preferred according to those decision criteria and those weights applied, and areas of red would be less preferred. So moving on to the next tool is a market redevelopment tool. And we did a binary logistic regression on a number of land attributes and property attributes to see which attributes of properties contribute to the likelihood of a property being redeveloped. So unlike a regular regression model that'll have a dependent variable as a continuous variable, this produces a binary outcome, a 0 or a 1, yes or no. So in this case, it would produce a value of 0 if no development is likely to occur, and a 1 if development is likely to occur. So these are some of the variables we found to be significant here in the top box. RPI is the redevelopment potential index, which is the ratio of the land value to the value of house plus land. So as this indicator approaches 1, basically just saying that all the value is in the land, and the capital improvement to the land has virtually no value at all. So we can slide that up to 0.8. We can look at some of the older dwellings in the area. We also know that zoning is statistically significant. So there's a lot of zoning in the city of Canning that's around R17.5, so we'll drop those out. We also know that the number of demolitions to happen in recent years in proximity to the properties is also statistically significant, so put that around there. And we'll remove vacant land from the query. So when we run that, it's going to indicate in blue the properties that have a strong likelihood of being redeveloped in the near future and may pose as opportunity areas for some redevelopment efforts to take part. So the outcome here, as you can see, we have 1,500 properties covering a total area of 144 hectares that currently has 1,505 dwellings, but a current dwelling capacity according to the zonings of 4,600 and achieved density of 10 dwellings per hectare. So it gives us some summary statistics about the areas we found. Now there's actually no blue properties appearing here on the map canvas, so I'll just zoom out a bit. And there you can see where they are. So actually the Curtin University campus is here in this area here. So there's a fair bit of redevelopment potential close to that university. So we can zoom into some of this green area. Now the next tool we added to the tool set was a zoning capacity tool, and this is because in the course of our research we also prepared a local housing study for the city of Canning that they required to assist them in producing a local housing strategy. And we use this tool to go around and rezone areas of strategic significance to higher densities and to be able to report on what kind of dwelling yields could be expected. So I'll go ahead and demonstrate how that works. I can add the rezoning layer. One can actually just go ahead and draw over top of the area they would like to rezone. You can rezone that, let's say, at 60 dwellings per hectare, because we might not expect development to reach maximum zone capacity. We might reduce that a little bit and say we might get about 85% of zone capacity in there. And save that. Run the calculation, and it adds that polygon here to this table, and it gives us some figures about that. And as we rezone more and more areas, they'll just get added to this table here, and the summary statistics will get produced up here. So what it's telling us is that this newly zoned area has a dwelling capacity of 148 dwellings, but we might expect at 85% efficiency there to be 126 dwellings, which produces a net capacity increase over current zonings of 75 dwellings and an expected net dwelling increase of 78 dwellings. What one can also do is calculate the number of dwellings that can be accommodated by the current power infrastructure. So we're running these calculations down here. This one on the left is based on substation capacity, and this one here on the right is based on collection district capacity. So I'll just review one of these here. It's telling us that this area that's been rezoned falls within one collection district that currently has a surplus capacity of 960 dwellings, and after redevelopment you'd expect there to be a capacity in that collection district to accommodate 882 more dwellings. So that's the zoning capacity tool. The final tool we have is a housing typology tool, and this is leaning towards module 3 of our project, which is wanting to visualize or imagine what kind of development might occur there in the future. So similar to the zoning capacity tool, you can add a capture layer, or we'll call it an area capture layer. You can find what area you might consider redeveloping and amalgamating the blocks. You can just draw over top of that layer. So that's this area here that I've selected, and it's going to amalgamate all the blocks that fall underneath that yellow translucent polygon. We'll execute those lot amalgamations. And what it's done is amalgamated the blocks that are touching by more than a specified amount. So if I zoom in a little bit, you'll see that these are now separate polygons. It also provides some review statistics. So we have 3 single lots. We have 1 amalgamation of 4 lots. And we have 2 amalgamations of 6 or more lots. And we worked with Monash University in Victoria, their Department of Architecture, and they produced some indicative typologies that could be achieved on certain types of lot amalgamations. So they are rough estimates, but business as usual figures are reported here in this left column. What they identified as being capable through advanced design is reported here on the right. So at the bottom, it's telling us that on these properties, business as usual will generate a dwelling yield between 19 dwellings and 38 dwellings. And the 19 would be indicative of a 1-for-1 redevelopment. You knock down one house and you build one house. And the 38 would be indicative of a battle axe subdivision. Under advanced design, the total yields are somewhat different, but generally greater. But not only that, they indicate that there will be a number of other positive benefits, not only yield, but ones related to open space quality, passive design, sustainable systems, affordability, and so on. And by redeveloping according to advanced design principles and some of their indicative designs, one could raise densities from 10 to 20 dwellings per hectare to something around 27 to 41 dwellings per hectare. Now what we've also added to the tool is the option to save to KML. We'll just call that trial. Now if I can just find this here on my desktop. There it is. We can open this file up in Google Earth, and that can be given to anyone to load up and view. And that will zoom us right into our proposed redevelopment area in the city of Canning, indicated there by the red outlines. Now this concludes the demonstration. If you would like any more information on the project, please contact Mike Ridout, the Communications Director at the CRCSI, and he can put you in touch with the research team.